Satyashri and Pujarini. Okay, thank you, Vinod. If you are listening and solving the questions, then please give me a thumbs up. Okay. Okay, I'm expecting that you guys are with me. So today I want to start with a question. So please try to solve this, and then we will go to the session. So the question is an investment of $500 today will avoid uh, $1 million damage to the environment in 100 years, and the discount rate are given. So you have to decide whether the investment plan is good or not. So for the case one, the discount rate is given 10%. For the case two, the discount rate is given 1%. And for the case three, the discount rate is given 2%. And then you are asked, what is the maximum willingness to pay for to avoid this environmental damage? So what maximum amount you will invest to avoid this damage? So this is related to Daly's principle. So based on this, like it's a mathematical formula you just have to use. So if you are with me, please try to solve this. Please give me a thumbs up if you are with me. Neha, and then Divya, and then I'm sorry, I'm not able to pronounce your name. So are you guys with me? Please give me a thumbs up if you are listening.
Yes, ma'am.
Yeah, okay. So we are solving this question. So I hope that you understand the question. This is the question. So please try to solve it, or you can tell me the approach so that we can discuss further. So I'll wait for another 2 minutes. Okay, so I'll ask Neha, uh, do you get the question? Vinod? Okay, so good evening, everyone, again. So first, we are today we'll start with a question. So I'm presenting a question. If you are familiar with this, please try to solve it. Otherwise, we can discuss it after that. So, Neha, are you able to understand the question? Okay, so
No, ma'am.
Okay. Anyone else? Paul?
No, madam.
Okay.
No, ma'am.
And Vinod, can you please give in the chat box if you are able to understand this? Okay. Satyashri. Okay, so now I'll give you a hint and then you have to solve it. Okay. So, what the question is trying to say is that right now we have to invest in certain technology or certain mitigation plan so that the environmental damage do not occur at the year 100. So what we are saying is that at t is equals to 100, sorry, at t is equals to 1, we have to invest the $100 so that at t is equals to 100, we don't have to incur the cost of $1 million. Okay. Now the question is the investment good idea or not to invest the $100 right now so that we are we are avoiding the pollution damage which is worth of $1,000 million. Sorry. So what we have to do is we have to compare this $100 right now with the $1 million after 100 years. So between this and this time we have 100 years. Okay. Are you with me?
Yes, ma'am. Yes, ma'am.
Yes. So now what you have to do right now is you have to find the net present value of this $1 million. Okay. So you have this $1 million 10 to the power 6, right? So this value, if you find the net present value, then the formula for net present value is as shown here. So the net present value formula is the RT upon 1 plus rate discount rate power time. Okay. So please try to find the so now net present value is R cash flow at time t upon 1 plus discount rate, that is I, to the power whole time t. Okay, this is my formula for net present value. Okay, now if you find the net present value of $1 million, what is the value? Please try to find this. I have given the formula, that is RT upon 1 plus I to the power t. So t is our 100 years, right? So for 100 year, if you are discounting the value of $1 million, what is the net present value which you have? Please try to calculate it. Anyone? Pujarini, are you able to solve it?
No, ma'am.
Okay, I'll repeat it one more time. Okay, okay, so it's not a problem. Now I'll repeat it one more time. So here we are given, we have two values, that is investment which we need is equals to $100. Okay. And future value. Future value is our $1,000,000. Okay. Now we have to compare this two so that if the investment is good idea or not. I hope I'm clear. Now to compare this, you have to find the this net present value. This is a future value, right? So you have to find the net present value of this $1,000,000. Okay. So to find the net present value, what we do is we find the value at time t to the power 1 plus I is our discount rate to the power t. Okay. So in this case, the future value RT is 10 to the power 6. I is our discount rate. So in the first case, that is 20%. So the value will be 0.2, right? Sorry, I think it is 10%. So the first value is 10%. So the value which you will get is 0.1. I value is 0.1, 0.1, and T value is 100. So at time after 100 year, you are seeing the cash flow. So can you now calculate the value of NPV? Yes, I'll wait for another 2 minutes. I hope that you understand the point which I'm trying to make right now. Anyone, if you come up with the answer for the first case where discount rate is given as 10%. So you are given discount rate of 10% and you are finding the value of $1,000,000 to the present value. Okay, so it's simple calculation that is $1,000,000 upon. So now we will get NPV is equals to 10 to the power 6 upon 1 plus 0.1 to the power 100, right? So can anyone help me with this answer? 10 to the power 6 upon 1.1 to the power 100. Neha? Okay, so the value which you get is around the value which you get is around 76 or something. Okay, so what we are trying to say is that now we are investment needed is 100. However, the net present value of future benefit which you will get is 76. So the net investment needed is more than net present value of future benefit. So I think it is a no, not a good idea. Okay, not a good idea because the benefit, future benefit is less than the investment which you are doing right now. Therefore, in the first case, when discount rate is given as 10%, that is 0.1, the investment is not a good idea. So that is what we are trying to say. So here, what we are saying is that if we invest in certain environmental goods right now, then what will be the future mitigation plan? So you are investing the $100 rupees in certain technology or in reduction of carbon or in reduction of certain emissions or in cleaning the water so that it will reduce the damage of $1 million. However, this $1 million value after 100 years is not equivalent to this $100 right now you are investing. Therefore, it's saying we are saying is that it's not a good idea when the during the case when discount rate is 0.1. I hope this is clear. Am I clear? Uh, am I clear? Please answer if you have any doubt or anything for the first case so that we will go to the second case. Uh, Neha, are you clear? Pujarini,
Yes, ma'am.
are you
Yes,
clear?
clear.
Okay. Seema, are you there?
Yes, ma'am.
Is it clear right now?
Yes.
Okay. Now, I'll request everyone to please find the second case. When the discount rate is given as 1%, then will it be a good idea or not? So same process you have to follow. So instead of discount rate of this discount rate of 0.1, what you have to do is you have to take the discount rate of 0.01, that is 1%. So please solve it for the second case. Now we are doing for the second case where the discount rate is given as 1%. So in the when the discount rate is around 10%, then the net present value of $1 million is less than 100. Therefore, it's not a good investment plan. However, when the discount rate which is around 1%, then will it be a good idea to invest or not? Anyone? Uh, okay, Paul, are you trying to solve this, the second case? Paul,
Yes, I'm
uh,
trying, madam.
okay. Yeah, please try to solve it. It's direct, but you have to take the value of 1% instead of 10% in this formula. Instead of I 10%, that here I have written 20. Instead of this 20%, you have to take 1%. Okay. Okay. Now, if you solve the second case, then you get the value as uh, you get the value as this much. Okay, 369711. I hope that you'll solve it, then you'll get the same. So in the when the you are investing only $100. However, the net present value is much more than the investment which you are right now doing. Therefore, in the second case, when the discount rate is 1%, it is a good investment decision. Okay, so in the second case, you are getting net present value of the future benefit which you are getting is more than the current investment which is needed. So in the third case, the discount rate is given 2%, and then you are asked that what maximum money you are willing to pay after 100 years to avoid this environmental damage. So it is same question. What you have to do right now is same, that you have to find the net present value. So the maximum money which you will be willing to invest right now will be this much: 138,032, 1 lakh 38,000 something, uh, so that $1 million worth of environmental degradation, environmental damage will be avoided. So here, what we are trying to do is that we are comparing the current investment and future value. So if you have to invest in certain technology right now so that our future environmental damage is avoided, then how much money you will be ready to invest so that the environmental damage is avoided. So that will be kind of a cost benefit analysis, that uh, current cost which you are incurring is $100 and the future value is million, or the maximum current cost which you will be ready to invest right now in the third case will be one lakh 38,000, and the future value which you are getting is $1 million after 100 years. So this present value which you calculate is by calculating by depreciating the value using the discount factor. So I hope I'm clear in this. If anyone have any question, please go ahead. So I'm presenting the answer right now for each of the question. Is it clear for everyone? Anjana,
Yes, ma'am.
Anjana, are you there?
Yes, ma'am.
Okay, thank you. So now we are moving forward to the next question. So it's already, you will see the answer, but okay, now we will move towards few question on Porter hypothesis, right? So in the last lecture, we have tried to understand till the Porter hypothesis and then the limitations of Porter hypothesis. So based on this we will try to solve few of the questions. So the first question is, Porter hypothesis states that environmental regulation could create competitive advantage rather than disadvantage on polluters, since the regulation could trigger technological innovation. So is this true or false? So what the question is trying to say is that by breaking in regulation, the polluter will have advantage rather than disadvantage. So here the polluters are firms which are emitting certain kind of emissions, or which are doing some environmental degradation. So is the answer true or false? You can put your answer in the chat box. Okay. Here we are saying this indirect, like in short, it is saying the regulation will be advantageous to the polluters. So is it true or false? Pujarini got her answer. Anyone else who want to try? Please. Okay. Anyone else? Okay. Now we will Okay, so the answer is actually true because and the when we discuss about the Porter hypothesis, right, we have initially told that the regulation is not always bad. Okay, so we said that the regulation is not always bad. Sometimes the regulation will be benefited for both the sorry, sometimes the regulation will be benefited for both the polluter as well as the social. So that is the basic hypothesis which Porter had given, that regulation will bring in a higher efficiency in the mm, technological, in terms of technological innovations, in terms of better processing, in terms of reduction of emissions in any way which is possible. So the correct answer is true. Okay. And then the second question, Porter hypothesis refers to the idea that first option is profit maximizing strategy for firm is to avoid all voluntary sustainability initiative. Second one is firm may actually benefit from increased regulation. And third one is profitability and sustainability are the same thing. So no, I'm not taking the right answer. So please choose the right answer. Okay, this is not the right answer which I just put this. You can put in the chat box for the second question. Okay, okay. So for the first question, it is true. Okay, because the answer is okay. For the second, are you answering? Please write two A's if it is for two, and if it is for one, then it's different. So if you are answering for the second question, please try to write with two so that it gets easier for me. Okay, Neha got the answer. Anyone else who want to try? So that is what I just say, but the basic which you have to understand is that the right answer is this one, option number two. So here what we are trying to say is that when the regulation is imposed on a firm, then the firm may actually benefit rather than the static mindset which we have that the regulation will destroy the competitiveness of a firm. So that is wrong. That is what the Porter is trying to say. So the correct answer is option number two. So in this, if you have any question, then you can ask me. Then we will move forward with the next question. Okay. So for the second question, the right answer is firm may actually benefit from increased regulation. Okay. Is it clear, everyone? Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Okay. Thank you. So now we will move to the next part of the question. I'm sorry. Okay. Now, please try to answer this, or you maybe I think we should go towards the chapter first so that we discuss the chapter and then we will move to the questions. Okay, so it will be easier, I guess. That's some of you might have missed the previous lecture or this. So now I'll start the session first and then we will solve some question. Okay. So this is our course module. So we have already covered module one, that is the interaction between economy and the environment, and module two, that is welfare implications of national income and sustainable development. We have defined what is sustainable development, what is economic growth, what is economic development, and then we move towards the EKC curve, and then explanation of EKC curve, and then the limitations of EKC curve. After that, we move to the fourth module, which is externality and market failure, and then the fifth module, which is incentive design. So this in this live session, we will be around the module 4 and 5. So in the module 1, these are the things which we have covered. In module 2, EKC curve, and then limitations, and then the policy implications of EKC curve, and then what are the environmental quality indicators for which EKC curves are valid and for which are these are not valid, and then various conceptual and methodological limitations we have studied. After that, in the module 3, we have learned the difference between economic growth and economic development, what is sustainable development, what is the economic definition, and how to measure a sustainable development, and then the sustainability rules. So weak and strong sustainability rules we have defined, and then we have defined the implications, policy implications of a strong sustainable development rule. And then in the module 4, Daly's operational principle, indicators for sustainable development. So we will just go through the slides for the module 4. So Daly's operational principle of sustainable development, this states that if we follow 3 rules of Daly's operational principle, then the sustainable development will be achieved. So that is what he had proposed. So the first rule is the renewable resources. If we are extracting certain renewable resources, the rate of extraction should always be less than the rate of growth, so that we give certain amount of time for the regeneration. So this is our first rule of sustainability. And in the second rule will be in the next slide. And in third sustainability rule, the rate of emission should always be less than the absorptivity capacity of the environment. So let's say that the certain emissions are being done, like sulfur dioxide or anything, then the absorptivity capacity of air is limited. So the rate of emissions should always be less than this capacity of the environment or capacity of the atmosphere. So that is what the third principle is trying to say. And in the second principle, what we are trying to say is that the total revenue which we generate from any kind of from the economy should have 2 components. First is income component, and second one is investment component. So the income component should always the income component the can be used by the current economy. However, the investment component have to be reinvested in the renewable resources, so that at the end of the non-renewable resources, we have equivalent amount of renewable resources to use as a stock. Okay, so this is the principle which states that certain revenue from the non-renewable resources have to be reinvested in the renewable resources. So I hope this is clear. Now, uh, now the question is how much investment should be done? Like how much percent of the revenue should be invested in the future, so that we follow sustainable development, right? So the value of investment component, that is investment component of total revenue R, will be dependent on present stock of non-renewable resources. Higher the present stock, we don't have to invest in other resources, so lesser will be the beta, or lesser will be the investment needed. Higher the rate of extraction, more will be the requirement in the investment. Higher the rate of technological advancement, we will have immediate alternative technology to switch when the current stock of non-renewable resources exhaust. So there is lesser requirement of investment. And higher the discount rate, present benefit is higher, so lesser will be the beta. However, lower the discount rate, future benefit is high, therefore more investment should be done in the future. So that is the four factors which are affected by affected to which are affecting towards the investment component of the revenue. Okay, so if you have any questions, then you can ask me. I'm going fast because we have covered it in the last session also. Any questions? Any questions from Daily's operational principle? Then you can ask me.
No, ma'am.
Okay, then I'll move forward. Then we have learned about the indicators for sustainable development. We said that current indicators to uh, measure the economy, such as GDP, GNP, and NNP, do not incorporate it in the usage of non-renewable and renewable resources, as well as the environmental degradation which is being done. So this should be incorporated in the economy. So therefore, we have studied uh, two indicators. First one is green net national product, and then the second one is genuine saving. So then we have also learned about the limitations of Daly's principle. So in Daly's principle, we are using marginal abatement cost. However, the abatement cost which we take is single value. However, the cost of reducing emission for different pollutants is different. So that is not solved in this framework. After that, the challenge in calculation of present and future usage of renewable and non-renewable stock, or change in the stock of this resources is a big challenge. After that, aggregation issue, that is that different components of the indicator have different renewable and non-renewable sources here. Components have uh, different values. So these are the limitations, and then they do not consider the biodiversity. Okay, so after this, now we are moving towards the impact. Okay, sorry, these are not, my bad. These are not limitations of Daly's principle. These are limitations of current calculation of this GNNP, gross, gross net national product. Okay, the limitation, first limitation is the change in stock, delta N, R and delta R, and then the second one is marginal abatement cost calculation, and these are the limitations which we are discussing. So this is not the limitations of Daly's principle. This is the limitation of calculation of GNNP. Okay, so aggregation issues, issues in the calculation of change in stock, and then the marginal abatement cost which we have. So these are the one. And then we go towards the genuine saving, in which we have taken the depreciation of man-made capital, natural capital, and then present value of expenditure in education. So if we invest in the education, then we said that we are reinvesting towards the human capital. So that will be subtracted from genuine saving. And from here, it can be used as one of the indicators for sustainable development. After that, we have moved towards the old and new concept of environmental regulations on firm competitiveness, right? So in the all concept, what we say is that there is always a trade-off between the environmental regulation and firm competitiveness. Whenever a regulation comes into picture, there it will destroy the competitiveness of a firm, because the cost of following the environmental standard will reduce the firm's competitiveness. That is what we are trying to say in the old concept. However, in the new concept, Michael Porter and Wendell London proposed that with implementation of well-designed environmental regulation, the firm financial performance will be improved. So then the second one is that regulation may result in higher output with lower degree of pollution, which will be win-win situation for both the society as well as the firm. So the bigger question is that why will a firm not follow this rule? Like why will, if they know that by reducing the emissions or by imposing certain regulation, if their profit are improving, then why will they not do by themselves that certain standards have to be followed? So that is the question. So there are certain arguments in favor of Porter. So Porter said that when there is implementation of certain regulation, the firm will improve its financial performance, firm will have profit. So the first argument is that regulation will help the firm to identify the point where they are having inefficient in terms of process, in terms of technology, in terms of resource allocation, right? So first one is that regulation will help this firm to know that at what point they can improve their efficiency, so that the efficient utilization of resources are being done. For example, let's say that a coal power plant, conventionally, if this plant have certain normative, a certain number as their efficiency, and then certain number as their emission. If a new regulation come into picture with the requirement of higher efficiency or lower emission limit, then this plant will try to find different ways through which they can improve their efficiency or they can reduce their emissions, right? So this kind of things will happen after implementation of regulation. That is the first point. Then the static mindset. In static mindset, what we are assuming is that the firm uh, have tried to maximize their profit. So, however, in real, not any firm can totally optimize their output. So, by implementation of regulation, this maximization of output will be better, as this firm have certain ways through which they can improve their efficiencies. Okay. If there is any question, you can unmute yourself in between and then ask. So I'm moving fast because these are already covered in the previous lecture. So I just want to move faster. And then the third one is managerial inertia. So for any firm, they have certain way through which the things are being done. So they have certain reluctance to change their process, to um, change their way in which things are done, or adoption of new technology or anything, because it is involved with certain risk, and then a certain change in the uh, requirement of manpower or anything. So this managerial inertia will be broken with implementation of regulation. So that is the third argument. The fourth one is regulations remove uncertainty, that certain regulations are made for 5 years with emission reduction plan. So when you have to follow anyway the emission reduction, then the firm follow technological innovation, adoptions of new technology, so that this uncertainty for the next 5 years is not there. So if you implement the regulation which gives certainty to the firms, then this firm will improve their environmental standards. So that is the fourth point. And in fifth point, the regulation will gather information. This information give awareness to the firm the amount of emissions which they are doing. Initially, when there is no regulation, they are not aware how much emissions that they are doing. However, with implementations, they are aware. So fifth one will be this, and then sixth one is it creates a level playing field for all the firms to reduce emission, and then the regulation will require let's say that if if there is if there is requirement of implementations of certain technology, however it is not fully economical for adoption of certain technology, then the regulation will push the firm forward for emission reduction. Though though they are not able to generate the whole revenue out of new technology, they have to follow it because of the regulation. So that is the seventh argument. So limitations are that Porter hypothesis is purely empirical study. There is no theoretical framework, and then they do not talk about the cost of regulation, the amount of benefits which we get, or these are few problems which we have in Porter's hypothesis. Okay. Now, if we summarize indirectly, Porter is trying to say that there is requirement of market-based instrument rather than command and control uh, type of regulation, which will give the credits for those firms which are reducing emissions further to the standards which is provided, and tax are levied on those who are not able to fulfill this. So that is one of the biggest message which we get from Porter hypothesis, is that the pollution abatement should be market based rather than command and control type. So in command and control type, it can be like a firm is asked to do the emission reduction of certain limit. So that can be one of the thing, and another kind of command and control are usage of certain kind of technology in the production. So that can come under the command and control. So this command and control do not incentivize the plant to further reduce the emission beyond the limit for which they are given. However, if market-based instruments are taken into picture, such as emission tax, tradable pollution limit, then the firm will reduce emission beyond the emission limit also, because they are getting certain benefits to reduce further through certain permits or certain credits which they get beyond this limit. So uh, there is a uh, private sector who are overlooking profit-making opportunities through technological innovations, and policymaker can correct this market failure by introducing stringent regulations. So that is the conclusion. So this diagram is trying to say the environmental policy will induce environmental resource and development, which will further enhance the business performance. So here we have positive. The environmental policy will have positive impact on the environmental performance. However, environmental policy may reduce the business performance. However, if the firm goes for environmental resource and development, and they do some certain technological adoptions or innovations, then maybe the business performance will enhance. So that is what overall picture looks like in the Porter's hypothesis, which says that there may be win-win opportunity for both the society and the firm. So if there is any question, then you can ask. Otherwise, I'll move forward. Any question?
No, ma'am.
Okay. Now, in the week 4, we talk about market failure and cost theorem. So we have studied what is marginal abatement cost curve. Marginal abatement is the cost of reduction, the cost of reduction of each unit of pollution. So that's why it is called marginal. So for reduction of first unit of pollution, the cost is lesser, and when we keep on reducing the pollution, the marginal cost will increase. So the reason is that higher the emission, there will be more scope of abatement. However, when the emission gets reduced, then the scope of abatement is lesser. So it is hard to clean the environment which is clean. However, when the environment is not clean, then it will be easier for us to clean. So that is the what it is trying to say, that let's say that for the first unit of emission, for the first unit of abatement, pollution abatement, the cost is this one. However, when we move towards this 5, then the cost will increase. So the y-axis give us the abatement cost, and the x-axis give us the level of pollution abatement which is being done. So for each unit, the cost will increase. So I hope this is clear. Now, this is a McKinsey curve, which is abatement cost curve only. So McKinsey is a company. They in 2007 model U.S. energy system for 2030, and then they have derived that what will be the least cost, like from here. You can see 1.4, right? So for abatement, for the first abatement, what they can do is uh, adoption of new technology like onshore low penetrations, manufacturing of HFC. After that, residential buildings and retrofits, and then nuclear technology, and then natural gas and petroleum system management. So this abatement cost curve is for the whole nation. So if you have to reduce this much level, like this much level of pollution, then the cost is this y-axis. Okay, so from 0 to upward, this will be our cost which the society will incur, and from 0 to downward is the cost saving which the society will do. So for adoption of new technology, for adoptions of solar power, for afforestation, for biomass power co-firing. Biomass power co-firing is like in the thermal power, you can use certain level of biomass. So that is called co-firing. And then let's say that reforestation, afforestation of coastal land. So this will reduce this much level of pollution, and the cost is this much. Okay, so I hope this is clear. And from here towards this, these are positive, like this do not uh, cost us any money. This will do the saving, like let's say that conservations, okay, I have to check this, but like let's say that improvement of efficiency of certain technology will save our cost of pollution abatement. And then industry combine heat and power. So if you combine the heat system of a country and then the electricity system, then the pollution will reduce by this amount. The width of the rectangle will give the amount of pollution abated, and the height of the rectangle will give us the cost which we will incur. Okay, so and then here you can see that commercial buildings, CFL lightings, and then different kind of activities have positive or negative impact, have positive cost or cost saving, uh, beyond for which we can abate the pollution. Okay, so this is modeled for 2030 scenario for United States. So a similar kind of cost abatement is there for any kind of country. So initially, if we have to reduce the emission, then we will try to decarbonize our electricity sector, or we will try to improve the efficiency of our thermal power plant so that we use lesser amount of coal and produce higher electricity so that the net emissions per unit of electricity generation is lesser. So this is it. So here we are trying to say is that the width is CO2 equivalent and the height is average cost of avoiding 1 ton of CO2 equivalent. So I hope this is clear. So I'm just giving you an example of marginal abatement cost curve. So this is the additional unit of cost abatement, right? So in real, this looks like this. So it can be for a single firm or it can be for the whole country also. So if you have any questions, then we can discuss further. Yes, you can ask question in the chat box also. Paul, am I clear?
Yes, ma'am.
Okay, so anyone else want to know further, you can, I have mentioned the link here, so you can read the whole report also. So I just took this diagram to show that this is how the country plans for its cost abatement. Like if we have to decarbonize or if we have to reduce the CO2 emissions, then we will go towards the cleaner technology, and then here comes, we can see that coal to gas shift, right? Coal power plant is relatively dirtier than the gas power plant, so coal to gas shift will be costlier. However, the width will give us the amount of abatement and the height will give us the cost which the society will incur. So if you have any questions, then you can ask me. Neha, is it clear? Neha.
Yes, ma'am. Yes, ma'am.
Okay, so do you want to add any point? Then you can add also. Okay, now what we are trying to say is that now we will move towards here. Mm, let's say that we have certain marginal abatement cost curve and we impose a tax that is P. Okay, so the firm, okay, so till let's say that initially I impose the tax which is P. So this is my P curve, and my marginal abatement cost curve is this one, right? So let's say that if I have to reduce my abatement towards x1 from 0, then if I reduce my emission, my cost is this one, P1. If I prefer to pay tax, then I have to pay the taxed amount of P. So P is more than P1. So for all this till X star, I'll choose to reduce pollution. Reduce pollution. Okay. Now from X star, if I have to pay tax, then I'll pay the tax of this amount. Okay, from here to here, this is my tax. However, if I choose to abate my pollution, then this is my point, which is, let's say I'm writing X. So my cost of abatement is higher than the tax. So at this point X, I will choose to pay tax. So after this point, let's say I'll write the bubble or something. So from here, then I'll choose to pay tax. Okay, so this is what we are trying to say, that for MAC less than tax, firm will choose to abate emissions. However, if marginal abatement cost is higher than the tax which is imposed, then firm will choose to pay tax. Okay, then the optimality is that P is equals to MAC. So marginal abatement cost at the X star is my optimality, where my uh, tax and marginal abatement cost are equal. So till this point, the emission will be abated. So I hope this is clear. If you have any questions here, then you can ask me. We are going to do some questions on the same. So if you are not clear, then please try to understand it more. So in the case one, I am imposing only the tax of P. So in this case, the uh, in this case, the optimal abatement is X star. However, let's say that the tax is increased towards the P star, then the abatement will be X1 star. So more abatement will be there if the tax imposed is higher. Is it clear? Is it clear for everyone?
Yes, ma'am.
Okay. Do you have any question? Then you can ask me. If anyone have any question, then you can ask. Otherwise, what I'm trying to say is that with increase in tax, the pollution abatement will be higher, because let's say that in the case one, I am trying to abate my pollution till X star. However, in case two, the firm will try to abate its pollution till X1 star. So that is what uh, we are trying to say. Now, in this case, we are considering MAC star, that is marginal abatement cost after adoption of new technology. So after investment in certain abatement technology, after investment in certain innovation, then you get different abatement cost curve. So this is my MAC star. Okay. So MAC star is this one. So for each unit of abatement, MAC star is always lesser than MAC. So there is always a cost saving at each unit of the cost abatement. So if a firm choose to go for new technology, the cost of abating each unit of pollution is lesser compared to previous technology. So benefits of investment will be given by area, triangle OBF. Okay, then let's say that the tax rate is P1 only. Then if there is any credit system, then the firm will try to abate its pollution till PFC further. So total benefit of investment will be given by OBF plus BCF. So whole this area. So this whole area is given as the benefit for investment in new technology. Is it clear? Triangle OBCF or triangle OBC is the uh, benefit. So if you have any question, then you can ask me. Now we will move towards the next.
Excuse me.
Yes.
I just like to know, would you be able to give some kind of live examples, like as you have explained this concept,
Mm-hmm.
and like where a technology and abatement technology was actually invested and what results were seen? Maybe something like a live example. Would it be possible?
Yes. Let's say that uh, it it differs from firm to firm. If there is a coal power plant, right? So they have to reduce the let's say that the SOx production, sulfur oxide production is there for the firm. Okay. So if they have to reduce the sulfur oxide production, either they have to reduce their production of electricity, right? Or they have to use certain better coal so that lesser amount of SO2 is produced. Are you getting me? Or they can try to bring in a technology which absorbs the sulfur oxide. So they have 3 to 4 choices, and these are associated with cost, which might be lesser to higher to higher. However, this higher cost will reduce my tax burden or will reduce my falling into the emission standard for another 5 years. So if this new technology investment is benefit for me for the long duration of time, then maybe I'll go towards new technology. However, if I can do the small things and avoid the capital cost which I have to incur currently, which is little bit benefit but do not incur the whole revenue for the duration, then maybe it's not economically feasible. So this is one of the example which I can say.
All right, thank you.
Is it clear?
Yeah, yeah, I get it.
Okay, thanks. Now, I hope that this diagram is clear for everyone. So, MSC is initial cost curve, right? Let's say that we do not impose the uh, new technology, then the cost of abatement of each unit is this first line, MSC line. However, new technological advancement is being done, which will have lesser cost of abatement than this kind of curve which you can derive. Is it clear?
Yeah, it's clear.
Okay, now I'm going towards the next. Now, we in Porter hypothesis, they said that by stringent regulation, by imposing certain kind of regulations, the firm might have like it's profitable for a firm to invest in new technology or to abate its emission. Uh, so Palmer et al. Tried to prove it wrong by showing this diagram. Okay, so in this diagram, what we can see is that we can see MSC and MSC star. So in let's say that if we go from in MSC, P2 is my new tax. Okay, P2 is my new tax, and P1 is my initial tax, which is imposed. So now, if you go along MSC, B is better than H, right? So the firm will need to abate less. So the firm will choose B rather than H. Along MSC star, the firm will choose the point C rather than the point D. Okay. And between B and C, the firm will not prefer to go towards the new technology, that is the point C. So the firm will be reluctant at the point B. So B is better than C. So if we see the profitability, then we can say that B is always better than D. So the point here, the point B is always better than point D. So, point B is initially when there is no stringent regulation and no new technology. And point D is stringent regulation is there and Technological innovation is also there. Still, the firm will prefer point B over point D. So the conclusion is, if innovation was not profitable with a modest amount of regulation, then it is still not profitable even with a higher stringent regulation. So if you have certain regulation and if you try to improve the regulation thinking that the firm will benefit it from this, then it is not the case unless the innovation is economical or profitable on its own. So that is what the Palmer hypothesis or Palmer et al. Try to prove. So yes, you can ask question. Is there any question then you can ask? Otherwise, I'll move forward. Okay, Porter hypothesis said stringent regulation may induce investment. However, if it is not profitable, then the uh, if it is not profitable, then it is not profitable even after stringent regulation. That is what they try to prove with this diagram. Now we will try to solve a question. So this graph here we have given x-axis as the abatement and QA max is the maximum possible abatement. So now the question is, what is the total compliance cost if a firm choose to pay tax? So what is the compliance cost for tax? So you have to mention the area. So T is my tax, this T line is my tax, and this MC line is my marginal cost of abatement. My y-axis is the price and x-axis is the amount of abatement. So my the first question is that what is total compliance cost if a firm choose to pay tax? And then the second question is, what is the compliance cost for fulfillment of standard which the regulator set, which is QA standard? And the third is that you have to show the new marginal abatement cost curve. So for the first and A and B, I would like to request you all to please answer in the text box. What is compliance cost for tax and what is compliance cost for standard. Please write in the chat box. Yes, you can. Okay. Anyone, please try to answer this question. Mm, okay. I hope this is visible with this kind of screen sharing also. So no, this is not the ABC type of question. Okay, you are saying, hello, am I audible? Okay, am I audible?
Yes, ma'am.
Okay, so I got few answers. So you are saying BDF. Okay, and ADB. Okay, that is okay. Anyone else who tried? I'm not able. BDF. BDF is for which case? Paul,
So D, madam.
option D. Okay. Okay. Now I'll explain you one more time. You are close, but we'll go again. So here, what we have said is that the cost saving compared to tax case, right? In tax case, we are paying OADC. Okay. And in new technology, we are paying BFOBFC. Is it clear? Now, if we subtract this whole area and this area, then we get this area BADF. So for option D, the correct answer is BADF. Is it clear? What I'm trying to say is that initially, if you choose to pay tax, then this whole area you have to pay, right? Now you have a new technology which saves this much area. Okay, I hope this is clear. So the cost saving is BADF in the option number D, and in option number E, the cost saving compared to standard is this BDF. This now. Let me clean it one more time. So now in the option number E, we have first MC curve and second MC curve. So the cost saving will be this one, a triangle BDF. So if you have any question, then you can ask. This is for E case. Any questions? Or we will move forward. Is it clear for everyone? Paul, is it clear?
Yes,
Ma'am, can you
ma'am.
explain
Y-
the
Yes. Which part you want me to repeat?
the last option, ma'am, the E1?
Okay. The E1, what we are saying is that if a firm choose to pay the standard, right? Then they will follow the marginal cost. Okay. So initially the cost that they have to incur is O, B, D, and C. O, B, D, and C. However, with adoption of new technology, this marginal cost come down to the red line. So the new cost will be O, B, F, and C. So if you subtract this two area, then you get this middle area, that is triangle B, D, and F. So this will be the cost saving because of adoption of new technology. Is it clear?
Yes, ma'am.
Okay, any questions? Then you can ask me further. Is it clear, right? So now I am going to the, okay, now let's look into it one more time. Total compliance cost if they have to pay tax is OADC, OADC. Then if the firm uh, choose to abate its emission, then OBDC, OBDC. And then new marginal cost will be given by red line. And then the cost saving compared to tax will be A, B, F, D. Okay, it's not A, B, D, F, it's A, B, F, D. So A, B, F, D, this whole area. After that, the last one is B, D, F or B, F, D. So this triangle will be answer for the last question. So I hope this is clear for everyone. Now we will move towards the next question. So now let's say that level to which firm will abate if there is credit system for higher abatement. So the standard is QA standard. However, if I say that if you reduce your emission further, then I will give you some extra money for more abatement. Then till what point the firm will choose to abate its emission? Can someone answer me? Do you got the question? The question is trying to say that beyond the standard abatement which the regulation says, if you abate the pollution further, then you will get some credit, you will get some extra money, or you will get some permit. This permit will give you some money. So then at what point you will try to reduce the emission? So that is what it is trying to say. Okay, so here in this case, the answer will be Q dash A. Okay, at Q dash A, that is when marginal cost curve intersect with the tax curve. Here Q dash A is there, right? So till Q dash A, the firm will try to reduce its emission, and this extra triangle DFH will be benefited by new technology for further adoption, for which the firm will be given certain kind of credit or certain permit which can be traded with other firms which are not able to abate its emission. So let's say that I am able to abate further beyond my standard. However, if there is any other firm who is not able to uh, abate the minimum abatement level, then this firm will give the permit to the firm B, and then they will in turn give some money. So is it clear? Is the option F clear? Any questions then? Neha, is it clear? Option F? Now,
Yes, ma'am.
okay, now we will move towards option G. So here the cost saving of option F compared to all technology. Then this will be our whole triangle, right? So if you get certain credit, then you will get the triangle DFH as the extra credit because of new technology. So this whole triangle DHB, this is my triangle which will be the benefit of new technology. So this will both include, so this whole triangle, okay, this whole triangle will include the reduction in the abatement cost curve for the same firm, as well as further reduction for which this firm is getting certain credit. So this both are included. I hope this is clear. Now this is BDH, okay. BDH is the whole benefit which the firm will get. So now limitations of Palmer theory is that they are static in nature. They do not taken into consideration the interaction between pollution and firm as well as between the regulators. So rather than the static model, there should be some game theoretic approach which will show the behavior of regulator and firm with certain technology adoptions, or with certain regulations taken into picture by regulators. Okay, so the Palmer theory is static model. There is no regulator and firm interaction. So that is one of the limitations. However, this model still holds good for a certain level. So Porter theory said it's a win-win opportunity. However, there might not always be the true case. Another big limitation with the Porter theory is that Porter said that when there is stringent regulation, the abatement will be there by enhancing the by enhancing the firm's technological adoptions or process improvement. However, many a times the firm will try to bypass the regulation by paying some bribes to the regulator or to the midman or to anyone through which the transaction cost will be lesser than their benefit, which is that if they have to adopt technology, it will be costlier rather than paying some bribe to the regulators. So in the case when the regulation is very hard to achieve, then this firm will go for the bypass system. I hope this is clear. Now we learn about the supply and demand curve. So the market will decide the price by intersection of supply and demand curve, and we get the optimal price and optimal quantity. Okay, at equilibrium, we get the price P star and quantity which is being supplied, that is Q star. Okay, so the market is the medium in which the transaction is taking place, and we then learn about the social welfare. Social welfare is the sum of consumer surplus and producer surplus, or it can be also termed as uh, reduction of total willingness to receive from the total willingness to pay. So I hope that you are clear with this idea, with this concept, because last session also we have discussed it. So then the role of market will decide the price, quantity, and it will also decide who will produce, who will buy. So the producer will be the one who produce at least cost, and the buyer will be the one who are willing to buy at higher price also. And the economy is efficient allocation of resources. So the market will decide the allocation of resources. So a perfectly competitive market will have optimal price and optimal quantity. So any questions? Okay, any questions, then you can ask me. Okay, now we will move towards the conditions for maximum welfare, or conditions for a market to function properly. So the first condition is market should be complete. That is, every transaction in the market have to be happen. Every transactions have to be happen in the market, and every transactions should have some markets. Okay, so that is first concept. And then the second concept is all the goods and services should either be owned by a private entity or a public entity. So all the goods and services should have some owner. So if these two conditions are met, then the market will try to maximize the social welfare. That is the sum of consumer surplus and producer surplus. Now, however, not every uh, goods and services have property right, such as atmosphere, such as water, such as clean air, clean water, or anything. So the environment is a good or service which for which the property allocations is little hard. So in this case, and in the case of externality, then this will lead to market failure. So now we will learn more about market failure. However, the well-defined property right is defined by comprehensiveness, that is, all goods and services must be owned by someone. Second one is exclusiveness, that is, the all the benefit should be enjoyed by the owner, as well as all the cost should be incurred by the owner. And then the transferability. So the owner can transfer the property right to someone else. So this will give incentive for the owner to maintain the quality of these goods and services. And then the fourth condition for well-defined property right is that it should be secured. That is, no one can. That is, the property is under law and order of a government. So these are the features of well-defined property right. And then market failure. So market failure is a term or condition in which the market is failing to achieve its objective, that is efficient allocation of resources. So the market failure will happen in many cases. It is defined as an economic situation with inefficient distribution of goods and services. So if the goods and services are not allocated efficiently, then it is called market failure. So here the individual incentive for rational behavior do not lead to rational outcome of the group. So what in a competitive market or in a perfect market, the social welfare is maximized by maximization of individual profits, right? But when the market fails, then the social welfare is not maximized by maximization of individual benefits. So that is what it is trying to say. The biggest market failure happens for the environmental assets because the individuals objective is to maximize their profit. However, they produce some externality, they produce some negative impact on the environment, which the producer do not incur the cost. Let's say that there is a firm which emit certain sulfur oxide or certain pollutants in the air. If because of this dirty air someone else is getting ill, then they are not paying for the hospital bill of that person, right? So this kind of in this kind of situation, the producer is enjoying the production that they are doing. However, they are not paying the cost of a negative externality that they are causing. So in these cases there is a requirement of government interventions. I hope if there is any question, then you can interrupt in between. Now, what are the reasons for market failure? First one is externality. Second one is improper price signal. So the price signal for clean air, pollution, clean water are not there because the market valuation or the pricing is not possible. So in such cases, then the market will indicate that you can use how much amount of water you want, or you can pollute water as much as you want, because there is you're not paying for the pollution which you are doing to the water, right? So those in those cases the firm will overproduce, or the consumer will overconsume without paying the price which uh, they are building to some third person or to the environment. So in this cases, the market will fail. And then the imperfect market, where the market power is with a certain consumers or certain producers, such as monopoly system, will lead to market failure. So in market failure, the optimal pricing is not achieved. So now, externality. So, externality is defined as the action of consumer or firm directly affect other person's well-being or a firm's production capability rather than indirectly through changes in price. So, if let's say that there is a two firm, okay, one firm is a chemical firm at the first end of the river, and below this there is a fisherman. So, because of the pollution of water, the fisherman is incurring the cost, or fisherman is having a cost. So in this cases, the production of the fisherman is impacted because of the first person. However, the first firm or the chemical firm is not incurring the cost of this action. So this kind of situation is known as externality. So externality is when the activity of an economic agent involve a third person for which the third party is neither paid the compensation for any cost incurred by him or her. In this case, it is called negative externality, or the third party is paying anything to the owner when the third party is getting some kind of benefit. That is positive externality. So the example of positive externality can be like, let's say that my neighbor is playing some music, very beautiful music, and I'm enjoying the music. Then this kind of situation can be called as positive externality. Or let's say that because of forestation of certain people for production of apple, they are impacting a cleaner air, because of which the locality is having lesser health impacts. So this kind of situation can be called as positive externality. Okay, now we will move towards the cause theorem. Is it fine if I take another 5 minutes? Sorry, another 15 minutes, if you guys are there. Hello.
No
Uh,
problem, ma'am. No
okay,
problem, ma'am.
I will cover the cause theorem because you will have to solve the assignment. So if you guys are comfortable with this, then I'll continue. If you have any other work to do, then you can go on with you can leave the meeting. So I will cover the cause theorem and then we will end the session. Okay. Before that, if you have any question, then you can ask me any kind of question or any feedback or anything. Pujarani, any question, any feedback? Today we have I'm Eshwari. Eshwari? I'm not able to
No,
pronounce
ma'am.
any.
No, no questions. It's okay.
Okay.
We can
Am I
continue.
pronouncing it right? Eshwari?
Ishwari. Yeah.
Ishwari. Sorry, my bad. Ishwari. Okay. Any more feedback or anything, then you can ask. Otherwise, I'll continue with the course theorem and then
Would you give us this presentation, because we see like I see that it's clear. It's simple sentences to understand.
sure. Actually, you will get access to this from the Drive link. So there is a Drive link which you will get in the mail also, and which is there in the portal. So if you go to SWAM portal, I'll
Hmm.
show it right now only. Okay, so we'll go here. Okay, and then we will go here. Let's say problem solving session is there, right? So if you click here, then you will see that recording. So if you go to recording, then you will get the Drive link. So here you will get the whole presentation as well as the recording of each of the lecture. Okay,
Okay. Okay.
so it's there in the link. So you can here click the link, right? So if you click the link, then you will get the Google Drive. So you will get whole link of YouTube links as well as Drive link. So this is my Drive link.
Okay. Got
Okay.
it.
Okay. Now we will again move towards the course theorem. So till externality and market failure, I hope you are clear. If you have any question, then you can ask me. And many a times there are few like complexity because of my way of speaking also. Then also you can ask me again. So now we will move towards the course theorem. Okay. So now course propose that if there is well-defined property right. So the well-defined property right have several features, right? Comprehensiveness, secure, and then transferability. So if it is well-defined and the transaction cost is free, then the bargaining between polluter and pollutee will result in the efficient amount of pollution. So there is no requirement of government intervention. Okay, so what he is trying to say is that efficient level of pollution can be achieved without government interventions. Okay, so the two condition is that property rights should be either with the polluter or pollutee. So it should be defined, and there is no transaction cost. Transaction cost means that let's say that I'm owning a uh, I'm owning a river. Okay, the river is owned by me, and you are polluting the river. And if you pollute, then I have to clean the river, right? Because this is my river. So you are the polluter and I am the pollutee. So you are let's say that a leather producing firm. Then you have to give me certain money because you are polluting my water, right? So we will bargain each other. So between us, if we have to bargain, then I don't have to come to you spending hundreds of rupees as my transaction cost. Like if we have to do the transaction and there is some cost incurred, then the transaction cost is not free. However, in cost theorem, it is saying that the transaction cost is free. Okay. Now, what the cost theorem is trying to say. We will try to learn from this figure. Okay, now this is the pollution. My x-axis is the level of pollution and my y-axis is either cost or benefit. Okay, so my MB is marginal benefit of pollution. So the marginal benefit to the uh, polluter by polluting. Okay, so marginal benefit of good producing. So if the leather company, let's say, then their marginal benefit curve is shown here. Okay, so if they pollute certain level, then they have more benefits, and then their benefits reduce to zero. Okay, then the marginal cost of pollution. So this gives the marginal cost curve which we have. Okay. Now we are saying that the property right is given to the polluter. That is, let's say that the water is there. However, the water is owned by the leather company only, and then the production is also being done by leather company. Okay, then if there is no negotiation, then what you will do? The level of pollution will be till OB. From O to B, the O to B till the marginal benefit. This marginal benefit becomes zero. The leather company will pollute the water because they are benefiting out of it, right? I hope this is clear. Now, the benefit to the polluter will be this whole area, OAB. The polluter is getting the whole money, that is triangle OAB, because of production of certain goods, after which they are polluting the water. Okay. After that, now I am the pollutee. So I have to clean the water. Let's say that I am a fisherman. So I have to clean the water because my I am getting negative impact out of it. But the water is not fine. Still, I have to clean it so that my production is improved, right? So then the cost which I have to incur is OBC. So this is the cost which I have to incur to clean the OB level of pollution. I hope this is clear. Now, the total social welfare is given by triangle OAB plus triangle OBC. So, in real, these two triangles are opposite of each other, so they get subtracted. So, triangle OAB minus triangle OBC will give us the social welfare. Okay, I hope this is clear. Pre-negotiations. Okay, any questions then you can ask. Okay, now what will happen is that now let's say that I go to the leather company because the water is damaged and I'm requesting that please reduce the emission. I will pay you some money. Okay, so let's say that the okay now if there is no negotiation till this point, the pollution will be there, right? Till point B. Now I am requesting the firm to come till this point. Okay, let's say that point X. Okay, now if I say that please reduce this level of pollution emission. Okay, then the polluter will say, why will I give you why will I reduce my production, because you are benefiting, but it's none of my business, I don't care. Then I'm saying this much level of money. Okay, this much level of money I will pay you, but please do not pollute. Why? Because if you pollute, then this much money till from here to here, okay, this much money I have to spend to clean the water. However, if I pay you bribe, I'm coming till point, let's say K. Till point K, this is my XK is the money I'm paying to the polluter. Okay. However, if I have to clean by myself, then XK dash will be the value, right? So then he said, okay, I'm getting money anyway, you are paying me bribe. So after that, again, I said, please reduce it furthermore to X1. Okay, I hope it is clear. X1, because still my marginal cost is higher than the bribe which I have to pay. Then I said, please come to X2. Okay, because here also the price which I have to pay is higher, right? So this is the price. I hope that these are clear. Okay, so the bribe will happen till the point M. I hope this is clear, because at this point, at point M, then the marginal cost of abatement for me is equal to the bribe which I am paying to the polluter. Okay, so till M, the uh, pollutee will give bribe to the polluter. Okay, so the level of pollution is OB. So sorry, the level of pollution is not OB, it's OM. After negotiation case, right? So it's, I'll change it later on. But the level of pollution is OM. So MB will be abated. Till MB, the abatement will be done. Then the benefit to the polluter, will be O OBC. Okay, and sorry, OAB. The this area will be the benefit to the polluter. Okay, now I'll move to the benefit to the pollutee. Okay, so the pollutee will, okay, uh, cost to the pollutee will be OBC. Mm, okay, now after negotiation, the cost to the pollutee will be this much. Okay, OBC will be the OBC. No, the cost to the pollutee will be, okay, this will be the benefit to the, this will be the benefit to the polluter, and this is the bribe which the pollutee is paying. So the cost saving the pollutee is doing is triangle DQC. So this triangle is the cost saving. Okay, so this triangle is the cost saving, and social welfare is given by OAB minus O. Uh, social welfare is given by CQ. Okay, I'll have to check it one more time. but the pollutee will do the cost saving, which is C, T, and Q. Okay, so this is the case. Now we'll go to the second case and then we'll come again. So now bribe paid to the polluter by pollutee till the point M. From B to M, the bribe will be paid to the polluter. Okay, so till bribe cost is less than the cost of pollution, cost of cleaning pollution, the pollutee will give money to the polluter. Okay, so DM is the optimal bribe, and when the bribe is equal to cost of cleaning pollution, that will be the optimal level of abatement. I hope I'm clear. Now, the benefit to the polluter. Benefit to the polluter is given by production benefit, that is area OADM, and then the bribe which they are getting, that is D, the bribe which is getting DQ, B, D, Q, and M. So this level of so total this whole area, like if we add the OADM, OADM and uh, BQDM. So this whole area is the benefit to the polluter. Okay. So the level of bribe is decided as DM. So till this like this DQ is the line of bribe. So whole benefit that they have to taken into consideration, which is the production benefit as well as the bribe benefit. So that is why we get this whole area. Okay, now acha, if it is confusing, then we'll discuss it one more time. But if till this point is there any question, then we can you can ask me. Is there any question till this point? Pujarini, is it clear?
Yes, ma'am.
Okay. Paul, is it clear?
Yes, till that portion is clear, madam.
Okay. Ishwari,
The rest of the portion is not clear.
Yeah, I'm following. I'm following.
okay, sure, thank you. Okay, I'll go forward, but since it is little bit was case one to case two, I'm also losing the track, so we will go with the flow. Okay, so initially we said that when there is no negotiation and the property right is with the polluter. Okay, the polluter is having property right. So the level of pollution is OP. Benefit to the polluter is triangle O. The benefit to the polluter is triangle OAB, and the cost to the pollutee is triangle OBC. So this whole area is okay. So this is clear, I guess. Now, if we move towards the negotiation case, then now I'm repeating it one more time here. Okay, so the negotiation case here, the a bribe the which the bribe which the pollutee is given. Okay, the pollutee is giving some bribe which is equal to DM. Okay, that is my optimum bribe which I am paying. Okay, so the optimum bribe is given by the condition where bribe is equal to cost of cleaning the pollution. So when the cost of cleaning pollution is higher than the bribe, then I will prefer to give you the bribe. Okay, so the benefit to the polluter is given by this production area. Okay, and this bribe area. Is it clear? So the whole area is triangle triangle BQDM and triangle OADM. So this whole area is benefit to the polluter. I hope this is clear. Okay, now
Yes, ma'am.
Now, benefit to the polluter, we have got it. Now, net benefit to the polluter is increased by triangle BGQ. This area is increased, right? For the polluter, the net benefit is increased. Okay. And uh, now, in the pollute case, okay, in the pollute case, if I have to clean whole area, then this is my whole area, okay, this triangle. If there is no bribery case, then I have to pay the whole triangle, that is triangle OBC. However, I am requesting the polluter to reduce the emission till point M. So, what is my cost saving? Till point M, there is no pollution. However, I have to pay this amount of bribe. Okay, so this amount, this area, this triangle DQC, triangle DQC is the cost saving which the pollutee is having. I hope that this is clear. So in this 2.2 slides, I have cleared everything for the negotiation case. So this slide is for the polluter. The polluter is having extra benefit because the pollutee is paying me bribe. The bribe amount is equal to BQD. And in the case when the for the pollutee, the cost saving is equal to DCQ. So for both the polluter and pollutee, there is a net gain because of negotiation. So post-negotiation situation is efficient compared to pre-negotiation situation. So that is the conclusion of cost theorem negotiation case when the property right is given to the polluter. Okay. Now, let's say that in the case 2, when the property right is given to the pollutee, now what will happen? Now the leather company is there and I am here. My water is safe now. So if there is no negotiation, then I'll not allow the leather company to pollute anything, right? So the level of pollution is zero. And the benefit to the polluter. The polluter cannot produce anything, so the benefit is zero. The cost to the pollutee. I don't have to clean anything, so the cost to the pollutee is zero. However, this case is not optimal. So here the property right is given to the pollutee. However, the social welfare is also zero. Okay, so the objective of any economy is to maximize the social welfare. However, if the leather company do not produce anything, then the social welfare is not there. So this is not the optimum case as the social welfare is zero. Now, what we are doing, we are negotiating. Okay, so now the polluter comes to me, then says, okay, I want to pollute your water because I want to produce certain amount of good, and I'll pay for the cleaning. So you have to clean the river and I'll pay for it, but please make me pollute the water for a while because I have to produce certain good. Okay, then the optimum compensation which I will ask is DM. Okay, DM is the optimum compensation which I will ask. Okay, the optimum compensation is given by marginal benefit is equal to the compensation. So the when my marginal benefit and cost of abatement are equal, this case is known as the optimum compensation case. Then the level of pollution is this much. Okay, and benefit to the polluter. Benefit to the polluter is given by AOMB. AOMB, and then they have to give some compensation, that is OMDQ. So this is the compensation that they have to give to the pollutee, right? So this, if you subtract this, then you will get the area AQD. right? So it's not AOM. This is AOMD minus OMBQ. So here what they will do is AO, AOM B minus OMDQ. OMDQ. This is the compensation. So AQD. So this is not B, this is D. Okay. So this is my whole production. This is my whole production area, out of which I have to give the compensation of this area. So this is my cost saving. So this is my benefit. So the triangle AQD is given as a benefit. Okay. And then the for pollutee. So for pollutee, DQ, right? O M and DQ. This whole area, out of which I have to spend this smaller triangle to clean the pollution. That is, triangle ODM will be used to clean the water. So my benefit is triangle OQD. So this is the benefit to the pollutee. So the net social benefit is given by triangle AOD. So the summation of both the benefit gives us the net social benefit, that is triangle AOD. So I hope this is clear. Any question then you can ask?
Madam, benefit to the polluter, how does
Yeah.
it come this OMBQ?
OMD, sorry, OMBQ. So this is the
Yes.
compensation that they have to give, right? Let's say that if I am producing certain amount of good, I have to give the compensation to the pollutee. So total production will be till M point, right? So till M point, if the firm produce, then the benefit initially will be OADM, right? OADM will be the total benefit. However, out of this, I have to give certain money for compensation, that is OQDM, to the pollutee. So there is negotiation. So this is the money to be given to the pollutee. So therefore, we have to subtract it. So is this your question? OMDQ will be subtracted. Sorry, OM, it's not BQ, it's sorry, this is a typo. I'm sorry. Yes, OMDQ. Is it clear
Okay,
now?
ma'am.
My bad.
Yes, ma'am.
Okay, so I hope this is better now. There are few typos. I apologize for that. And then we are ending with the conclusion that if you compare case 1 and case 2, in both the case, the the post-negotiation case is better than pre-negotiation case, right? Let's say that in the second case, when the property right is given to the pollutee, initially the social welfare was zero. However, in this case, the social benefit is triangle AOD. So the society is getting benefited by negotiation. So we conclude that the emission zero is not the best case. The optimal emission is the best case because we have to maximize the social benefit. So compared to pre-negotiation situation, post-negotiation result in net benefit in both the case in which the polluter is having the property right or pollutee is having the property right for both the polluter as well as pollutee. Okay, now the costless negotiation results in the same level of pollution. So in in both the case, the level of pollution is OM, right? Here also the level of pollution in the case 1 is OM and the level of pollution in the case 2 is also OM. So the level of pollution is in both the case OM. Okay. And in case 1, the indirect benefit to the pollutee is there because the pollutee is saving certain amount of money, that is triangle DCQ, right? However, there is no positive benefit. So this triangle DCQ is money which I am saving, otherwise which I have to invest for abating the pollution. However, there is no positive benefit. But when the property right is given to the pollutee in the case 2, then the positive benefit is there beyond the beyond the cost saving for abatement. So here in the case 2, triangle DQO, right? Triangle OQD is the net benefit after subtracting the triangle OMD. Triangle OMD is the cost which I will incur to clean the pollution. However, this triangle OQD is my positive benefit. So in the case 2, the pollutee is having net benefit. So that is the conclusion. So if we conclude, if for me case 2 is more preferable because I am the pollutee, but for the polluter case 1 is more preferable because in case 1 they are having higher benefits. So with this, we conclude the course theorem. If you have any question, then you can ask me. I hope I am clear. So, any question, or we can end the session. Okay. So I hope I'm clear today. Uh, Ishwari, any suggestion or any question which you want to ask?
No, it's fine. Maybe I felt like I followed what you were explaining, but maybe I have to see one more time. No, I have to go through it so that it stays properly in my mind.
Sure,
I was
sure.
able to understand what you told, but
Uh-huh.
it's still slightly. I feel like here and there I'm slightly confused.
Sure, sure, sure. Please go through the PPT, which will be in the drive, or you can also go through the lecture which is uploaded in the NPTEL portal. And if you have any further question, then you can ask in the discussion forum, which is there, or you can ask in the next session. So that is all. And with this, I will end today's live session. I would like to thank everyone for your patience. And that is it. Thank you. So any
Thank you.
questions, if you have, then you can mail me or you can ask in the portal. Okay.